All right, so now we are finally on to something different, no tables needed. We're going to be looking at some models to predict some things in the future, and we're going to start with linear regression equations and applications. So we are here in chapter 12. And it's nice to start off with because this is very algebraic. So if you had a good time in algebra, this section will be real quick and easy for you. And if not, as always, I'm happy to provide you with some algebra review problems, and it will just be on graphing. Algebra review. Okay. So what we're going to be doing is we want to determine whether there is a correlation, which means an association between two variables. And if there is the correlation linear? That's the one we're going to focus on. We will talk about nonlinear. I'm going to highlight it. Oh, there we go. We will talk about nonlinear correlation, but we're focusing mostly on linear. Okay, so two things that can be correlated, for example, would be a parent's height and their children's height. And so if we just made a quick little sketch of that, if we have maybe the kid down here and the parent over here, and we would say, typically, people a short child. There's some data, in green. There's some data on this graph, and as the kid, not as a kid, but as the parents are taller, the kids are probably taller. And that doesn't necessarily hold true for everyone. You can have a child or one of your kids grow up and be short, even if you are a tall parent. And you can have a kid that is very tall, but their parent is very short. So it doesn't necessarily follow this straight line, but we notice a lot of times there's some sort of pattern to it. And so here, the picture I drew, there's definitely not a straight line. You couldn't connect all these dots, but we could draw a line through them, and that is where we're getting this regression equation. The line doesn't necessarily describe every single dot, but it describes the overall pattern. All right, so what we're going to go back and look at is the line y equals mx plus b. So y hat is our predicting. This is our that's going to be what we're predicting for our regression line. And so we're going to use the form of y equals mx plus b. So just as a reminder from algebra, we have the y-intercept, the point, in this case 0, 6, because that is our y-intercept. And then we have our slope over here is -2, and sometimes people like to write it as fractions because at -2, 1, because we're going to go down 2 for the negative, and then write 1. And again, if I'm going through this too fast, just send me an email, let me know, and I will happily send you some more instruction on some algebra review. But again, the y-intercept is 0, 6, so I can plot that. And then the slope of -2 over 1 means I'm going to go down 2 spaces over 1. Oops, I didn't mean to make that dot. It's very important that the dot ends up where you land. So again, I went down 2 over 1, and that's where I make my dot. And by connecting all these dots, because I'm graphing a straight line, I can connect the dots and make that straight line. This is linear. All right, so again, we're going to do this. Notice on this problem, it's written backwards of how it was on the first problem. So the first number is not the slope. The slope is the number that's with the x. So if you prefer, you can rewrite this as -3x plus 10, and then it will follow the same format with the 0, 10 being the y-intercept, and then the -3 over 1 being the slope. So I'm going to go down 3, and oops, again, that first dot shouldn't be there. And then down 3 over 1, and connect the dots because we are making a straight line. And there's our linear equation, or our picture, our graph of our linear equation. Okay, so how does this relate to statistics? I know this is a huge jump, from the hypothesis testing. But this is just another facet of this class. And so here we have an example, and it says that an occupation expected to have a large growth of employment in the next few years is computer software application engineers. The number of people, Y, and notice it says in thousands, so we will need that for later, employed as computer software application engineers can be estimated by the line Y equals 17.5x plus 15.5. So the first, oh, and then it says, here's the other hint. X is the number of years after 2008. All right, so what we're going to do is we're going to graph this. Now, I'm not going to get it perfect. I'm not going to be able to graph 17.5 and then 15 or 515, but I can get a good estimate. I'm going to count by hundreds. 1, 2, 3, 4, 500. And that's my y-intercept is 515. And then the slope is 17 over 1, 17.5 over 1. Am I going to get this perfect? No, but it's definitely positive. So my slope is going up. So the line is going to look like this. It's just to give us a visual. It's just a quick little sketch of what's going on in this problem. All right, now it says to use the graph to predict the number of application engineers in the year 2020. It's going to be hard to do on this graph because it is just a sketch, but I can use the equation y equals 17.5x plus 515 in order to solve this. I forgot my x. All right, so the only thing is, what do I plug in for x? Going back to the equation, it says x is the number of years after 2008. So what I want to know is how many years after 2008 is 2020, because that's what the question's asking about, is the year 2020. So we can just say, okay, 2020. Some of you just look at this and know. Other people want to write fine, we subtract, and we get 12 years. So in this example, x is going to equal 12 because x is the number of years after 2008. So I take my y, whole equation, and then I plug in that 12 in for x. Throw that into your calculator, and you get that y 725. All right, so 725, that does not sound like a lot of people. It seems like in the year 2020, there'd be a lot more engineers than that. So go back to the problem, and it says the number of people, there's a y there, let me erase that. The number of people y in thousands. So this 725 is in thousands. Oh man, tried to write and I had my highlighter on. Let me erase that real quick. And we have, you can either write the word or you can just write the zeros. And we have 725,000 engineers. Then, let me pause that. Okay. Here we go. And so what we have for this next problem is we have Diane's monthly bill for cell service. Okay, there we go. So Diane's cell service bill can be computed using a linear equation. When she uses no data, the bill is $37.50. When she uses 2 gigabyte data, the bill is $45.50. So what are the independent and dependent variables? So the independent is another word for x, and dependent is another word for y. So we're getting ready to set up our equation. So think about it. Which one affects the other? Do you have control over how many gigabytes you use, or do you have control over how much your bill is? Well, they figure out your bill from your choice of how many gigabytes you use. So the amount of data used is the independent variable. That was in gigabytes. And then the dependent variable is the bill, or the amount of money, would be the y variable. So we use this equation, y equals 4x plus 3750, to figure out, or so we can use this equation, and it says what is the slope and the y-intercept. So from algebra, the slope is m, and the y-intercept is b. And that equation from the other page was y equals mx plus b. So the slope is what's in front of the x, which is 4. The y-intercept is what's at the end there, which is 3750 or 37.5, either way. So if Diane uses 5 gigabytes of data in a month, what is her total bill? Gigabytes, remember, that is our x variable from part A. So we can plug in y equals 4 times 5 plus 3750. And plug that into your calculator. And you get a final answer of $57.50. Don't forget the dollar sign, because that is the amount of her bill. Another way to look at this problem is, well, if you know what her bill is, how much data did she use? So her bill, remember the bill is y. So if the bill is for $49.50, what is the x that correlates with that? So we will subtract 3750. And then finally divide by 4, and we get that x equals 3. And as a reminder from the top, x was in gigabytes, so she used 3 gigabytes if her bill was $49.50. All right, so looking at some examples of scatter plots. We have 4 examples here, and the top 2 are the most common that we're going to distinguish between, because these are linear patterns. So both of these have the word linear in them. And notice what I was talking about before, where I can draw a line through this data. The positive linear pattern goes up, just like the slope. And so this one, the slope is positive, and we call it positive linear pattern. On the second picture, the slope is going down, the slope is negative, and we say that's a negative linear pattern. So both of those, even though they don't make exactly straight lines, they kind of have an overall pattern to them. The third example, it says no pattern, because if I drew a line one way, I have a whole bunch of dots on both sides of that paper, of that line. They're very far away. It doesn't really describe the line. And if I drew a line the other way, I still have a whole bunch of dots that are very far away from the line. That line does not describe that picture either. So there's no pattern here. It kind of just looks like somebody took a salt from pepper thicker and dumped it all over the table, and there's no pattern to it. So that would be no pattern. And then finally, we have a nonlinear pattern, because I could describe this. It kind of looks like a rainbow. So I could describe it, but I couldn't describe it with a word that means a line, because rainbows are not straight lines. So it does have a pattern. The pattern is just not a line, or in other words, non-linear. Okay, so we are going to create a scatter plot, and we are going to then use our calculators to help us find the equation of the line. Because if you had a straight line, you could find an equation of that line using algebra. But if you have something like these top 2 pictures here, which are dots all over the place that kind of overall form a straight line, but the dots themselves do not form a straight line, then it is a little harder to just use the algebra to plug it in. So we're going to use the technology to help us out. But this one says first create a scatter plot. So first I'm going to plot these points. So I have the point 0, 2, 1, 4, 2, 6. Let's see, this first started wrong. Probably yelling at me through the computer. There we go, I heard you. 0, 2, 1, 4, 2, 6, 3, 8, 4, 10, and then 5, 12, 10 goes off the picture, but we get the point. This one actually makes it good. Just after drawing this picture, I could describe this straight line, not making an exact line because I don't want you to typically draw lines through them. However, we can see that it does form a straight line. So we could use our slope-intercept form to say, okay, well, the y-intercept is 2. And then the slope to get from one dot to the other, let's see, get from here, then I'm going to go up 2 and over 1. So my slope is 2. My slope is up 2 over 1, which equals 2. Okay, so yes, there's some algebra involved in that problem. However, we didn't, some of you might not have really followed along because it's been a while since you did algebra. So I'm going to take a minute and do this same problem on the calculator. And so in order to do that, I'm going to stop sharing because I want to be as big as possible for you to see my calculator. But the very first thing, I'm going to do it on this calculator first, and then I will do it on my graphing calculator also, because I know there's people out there that use graphing calculators. And I know I'm going to go through this kind of fast because I already have all the data programmed into my calculator. So as we go through the steps, just hit pause, get your data entered in, and then you can follow along. So the first thing you want to do is you want to hit the data button that we've been using for everything, because what we're going to do is make a list. Mine's not on. All right, so I hit the data button and I have already typed into the calculator. I have all the X's and all the Y's. So I have the using this same example. Where is it? This same example that we just did. I can't even point backwards. Okay, I'm getting the hang of this. The same example we just did, I'm just typing that into my calculator. So I have that in. And if you have a graphing calculator, then you can just, you know how to type the list in already. Okay, so now that I've done that, I'm going to do actually the same thing that we've been doing. And I'm going to hit stat, which is the green button, and then hitting stat. And we've been to this screen many times before. And every time we would hit one variable stats, but now because we have the X and the Y, we're going to use two variable stats. So I go down and hit enter, and I have two variable stats. And now it's saying, where's the X and where's the Y? So going back to this table, the X should already be in your first list. The Y should be in your second list. And so it should be L1, L2, and it should just always be that. If you just always leave it like that, then you won't have to change it. And I hit calculate. And it gives us a similar screen that we've seen before. The main difference is that it says two variable L1, L2 instead of one variable L1, L2. Okay, so what we're gonna do, this is so weird going backwards. Okay, I'm gonna scroll down. Keep scrolling, and I see A and B. A is the slope, B is the y-intercept. So we're going to use, so scroll down and make sure you can find A equals 2, B equals 2. And when I get back to the video, then, or when I get back to the screen, I'll show you how to plug those in. Okay, this type of calculator, graphing calculator, mine is pink, it's very pretty. Okay, so what you're gonna do is go to stat, and if you hit edit, it just puts your list in. So you should have your L1 and L2 lists put in, just like the other calculator. And then what you're gonna do is you're gonna go back to stat. So let me do that again. Oh, I just turned it off. Okay, back here. So I go to stat. You already typed your list in. So we're going to go over here to calculate. Two variable stats. You might have already figured this out while you were waiting because it's a similar way to start. Actually, no, we're not doing two variable stats. I lied. Okay, we're going to go down to this fourth one because what we're doing here is linear regression. And what I want to emphasize is that the fourth one and the eighth one look very similar, but we want to use the AX plus B version. So scroll down to AX plus B, and just like the last group, I don't know why this isn't coming in very clear. Oh, there we go. L1, L2 for your X and Y. Nothing else, no frequency, you're not going to store anything. Calculate, so I'm just hitting enter, or you can hit the down arrow to get there. And voila, there it is. I have my A, I have my B. I have some extra information. You may or may not have extra information. If you do, ignore it because we're not going to use it right now. If you don't have it, then in the 12.3 video, I'll show you how to get it because you're going to need that extra information, just not right now. So we have the A equals 2, B equals 2. And then for this calculator, it tells you right there, AX plus B is the formula. So you can just plug 2 in for A and 2 in for B. All right, so let me get back to my screen or to my notes. And what we have here, oops, share. Videos, you have to see my ceiling. Going back to the beginning, we have this formula that I highlighted, y equals ax plus b, or y hat equals ax plus b. So when I write this out from the calculator, a equals 2, b equals 2. The formula is y hat equals ax plus b. And so we can put that all together and get y hat equals 2x plus 2. And then what we can do from there is we can tell, and you can tell this from the picture also, but this picture has, this is what type of pattern is it? And this one is positive linear association. All right, so there is one more example. So go ahead and try this problem. You're gonna put it into your calculator. So go ahead and pause the video and put this one into your calculator and come back and check and see if you have the right answer. And we're back. Here we are. So you should have a picture on here that looks like this. So we have 1, 1, 1, 2, 2, 6. These are the greatest of dots, but this is just a sketch. 4, 5, 5, 8, and then 8, 13. It's going to kind of go off the graph, so it's up there. So I'm going to draw a line. Actually, not drawing a line because that's not what it's asking me to do. It says find the equation from the following table and what type of pattern is there. So by now you should have put this already in your calculator, and if you didn't listen to me before, pause the video, put that in your calculator to make sure you know how to do it. But if you have already done it, then what you should be getting, now first of all, you might not have written anything down because the decimals are kind of wonky on this one, so that's fine. It's more important to me at this point that you know how to put it into your calculator. Because hopefully right now, you either tried to write something down or you're looking at your calculator right now and just try to see what I'm going to do to write this down. So I'm going to write down to 2 decimal places, 1.37x plus 1.36. Just putting both of those to 2 decimal places. And then this one, I lied earlier. I'm going to draw a line. So I'm going to draw a line through here, and so I can see that it has a positive linear association. But it's not the same as before, because that one was a straight line, and this one, the dots kind of go off a little bit. So I'm going to finish it up by saying with some deviation. Some of the dots deviate from that line. In fact, I think all of them don't land perfectly on that line. They kind of go off a little bit. But that's okay. It's still positive linear association. It's just the way I tell that it's not a straight line is by saying with some deviations. All right, so that is all for this section. Email me or come to office hours if you have any questions regarding how to use your calculator, if you want any algebra review, or if you need any help with any of this, just let me know. I will talk to you later.